तलवार की धार से, ना गोलियों की बौछार से। बनना डरता है तो सिर्फ परवरदिगार से।
Hello everyone, today in this video we are going to talk about parallel combination of registers. We'll derive the formula for parallel combination and we'll use the formula to solve question on parallel combination of registers. So let's start the video. So if you have this kind of circuit, so we can easily find current using Ohm's law, and if you have this kind of circuit we can simplify this circuit. This is the series combination, so we already know for series combination we just need to add the resistor, so this can also be solved using this formula. But if you have this kind of question in which resistors are connected in parallel, we cannot use this formula, so we have to derive this another formula for this combination. So let's derive the formula. So first let's understand the properties of parallel combination. So this is a parallel combination in which all the components are connected across same 2 point. As you can see, all the bulbs are connected across positive and negative of the cell. This one also, second bulb is also connected across this same cell, so it is parallel combination. So in parallel combination all the component will get equal potential difference and different current flows through different components. So the property is equal potential difference, different current is the property of parallel combination. So we'll use this property to derive the relation. So let's derive the relation. To derive the relation I have to consider one circuit in which resistors R1, R2 and R3 are connected in parallel across the potential difference V, and I1 is the current flowing through R1, I2 is the current flowing through R2 and I3 is the current flowing to R3, and total current flowing through the circuit is I. If you add I1, I2, I3 you will get I, because this I is going out here and it is getting splitted into three parts. That means I1, I2, I3 are the parts of I. So, and I'll draw one circuit which is equivalent circuit in which potential and current is same, only I'll replace the parallel combination R1, R2, R3 by Rp, which is denoting resistance in parallel. So as we all know, in parallel combination potential difference across all the resistor will be same, so out here V is the potential difference across R1, R2 and R3. And for parallel I can write the current flowing through the circuit is equal to sum of current flowing through each resistor, that is I is equal to I1 plus I2 plus I3, because this I is getting splitted into three parts, so I can write I is equal to I1 plus I2 plus I3. Now I'll use Ohm's law for each circuit. Now for this circuit, as you can see, I is the current, V is the potential difference and Rp is the resistance. So if you use Ohm's law, V is equal to IRP, then you can write I is equal to V by Rp. So for this circuit current is V by Rp. So similarly you can use Ohm's law out here. So for current I1 you can write I1 is equal to V by R1, because V is same for all the resistor, only the resistance R1, R2 is different. So out here similarly I can write for this resistor I1 is equal to V by R1, for this resistor is I2 is equal to V by R2, and for this resistor is V by R3. So we'll put the values of I1, I2, I3 in the equation that we have got in previous slide. So that is I is equal to I1 plus I2 plus I3. Now I'll put the values. So if you put the values I1, I2, I3, so you'll get, so see, instead of I'm putting V by Rp. So instead of I1 I'm putting V by R1, similarly V by R2 and V by R3. And out here you can see V is common, so if I take V common, you are left with 1 by R1 plus 1 by R2 plus 1 by R3, and this 2V is same, so you can cancel V and V. So you are left with 1 by Rp is equal to 1 by R1 plus 1 by R2 and 1 by R3. So this is the final expression. So in series we have got Rs is equal to R1 plus R2 plus R3, but out here we have got the reciprocal. So we'll say the reciprocal of total resistance is equal to sum of reciprocals of all the resistance. So these are the properties of parallel combination. So as I've already said, in parallel combination, reciprocal of total resistance is equal to sum of reciprocals of individual resistance. So you have to reciprocal them and you have to add this. And in parallel combination, resistance decreases due to increase in cross section area. So if you connect these two resistors in parallel like this, if you connect them like this, so area will get increase, and as we all know, when the area increase, resistance decreases. And in parallel combination, total resistance is less than the smallest resistance. So if you are connecting 5 ohm and 2 ohm in parallel, so your combination will have resistance which is less than the lowest, that is 2 ohm. So the combination should have less than 2 ohms. So these are the properties of parallel combination. So let's solve one question. So here the circuit is given with 3 resistors, and I have to find the current, and I have to find the current flowing through R1, R2, R3. I have to find this current also, and I1, I2, I3 also. So first thing I'll make the circuit with all the currents. So see out here I have given I1 for R1, I2 for R2, I3 for R3, and remaining I'm leaving the same. So out here givens, what are the things which are given? R1 is given 5 ohm, R2 is given 10 ohm, R3 is given 15 ohm, and potential difference is given as 5 volt. So as we all know, they are connected in parallel, so I have to write the formula for parallel combination, that is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So I'll put the values. Now I have to take the LCM. So see, LCM of 5, 10 and 15 is 30. So I'll write 30, then 5 6 are 30, 10 3s are 30, 15 2s are 30. So I'm adding this, 1 6 are 6, 1 3s are 3, 1 2s are 2. So I'm adding them. So that is giving me 1 by Rp is equal to 11 by 30. So I'm getting 1 by Rp, but I need Rp. So what I'll do is I'll reciprocate. I'll just reciprocate both the sides. So that means Rp by 1 is equal to 30 by 11. So when you solve this, you'll get 2.72. So the resistance is, total resistance is 2.72. So now let's find the current now. So for this I'll make one equivalent circuit now for this circuit, so in which I'll replace the parallel combination of R1, R2, R3 by Rp. Then I'll use Ohm's law out here. So we already got Rp to be 2.72 or 30 by 11, and V is already there, so I can find I using Ohm's law. So V is equal to IRP. So IRP is equal to V. So I is equal to V by Rp. Now let's put the value. So for this Rp I'll not put 2.72 because of this decimal point the calculation will be difficult. So rather I'll use this 30 by 11. So this is 5 is the potential difference and Rp is 30 by 11. So this 11 will go up. So this will be 5 into 11 by 30. So if I cancel this 5 and 30, so you'll get 11 by 6, and if you find the value, the current will be 1.83. So next, now I have to find the current through each resistor, that is I1, I2 and I3. So these are the part of the question, as you can see, and current flowing through R1, R2 and R3. So let's see the circuit again. So I have to find I1, I2 and I3. So I'll be using Ohm's law one more time for each resistor. So this we all know, V is equal to IR1. So I1 is equal to V by R1. So we have got V and we have got R1. So V is 5 and R1 is 5, so this is 1 ampere. So similarly for I2 I can write V by R2. So same way I can find, that is 5 by 10, so this is 0.5 ampere. And I3 is again V by R3, so using Ohm's law out here, so 5 by 15, so it will come 0.33. so these are the result I have got. And if you see, if you add all I1, I2 and I3, so I got I2 be 1.83, and if you add I1, I2, I3, you will get the same. So that means your answer is correct. So these are all the answers. So equivalent resistance is 2.72 ohm, I1 is 1 ampere, I2 is 0.5, and I3 is 0.33, and total current is 83. So we have found everything. So this is all the answer in one page. So you can pause the video and copy this, and if you don't follow any step, go back and check how I have done. And these are the questions you can try by yourself. And please don't forget to like, subscribe.
ना तलवार की धार से, ना गोलियों की बौछार से, बनना डरता है तो सिर्फ परवरदिगार से।